Hello, this is John from caveofprogramming.com. In this video we're going to take a look at overriding properties in Kotlin. I don't think I actually know any other object-oriented language that allows you to do this, but in Kotlin it's useful and important, so we'd better cover it. We're going to need a superclass and a derived class to demonstrate this. Let's create a class which I'll call machine. And what I'm going to do is I'm going to try to write this naively, and we're going to see what errors come up and what keywords I'm forced to add in. So let's have a class computer, which I want to derive from machine. So the first error that we get here is it tells me the supertype machine has a constructor, so it must be initialized here. I need to put in those round brackets. There's no constructor that takes parameters, so all I need are those round brackets there. Then when I look at the error message, it tells me that machine is final, so I have to make it open if I want to create derived classes. And now I've got a valid derived class. So down here, let's say val computer equals computer with a capital C. Now let's imagine that machine has a property. It could be a property that we set from the constructor, or it could be a property that we don't set from the constructor. Let's create one of the latter for simplicity. So we'll have a val temperature, and that's going to be of type int, and I will give it a default. Let's say the default temperature of a generic machine is maybe 21 degrees Celsius. So by default now, when I create a computer, it's going to inherit that property, and I can view the property. So let's do print line computer.temperature and run it. And we can see the temperature is set to the default of 21 degrees. Now I decide that I want my computer to have a higher default temperature because computers are always wearing away, generating heat. So I redeclare temperature in computer with a different default. Let's say val temperature equals 30. And straight away I get an error here, and the error is telling me that this hides the corresponding value of temperature in machine. If I actually want to override it, it's telling me I need to use the override keyword. However, when I add the override keyword, I get another error, and this is telling me that temperature in machine is final and cannot be overridden. In order to be able to override it, I have to declare the temperature is open. And now computer has an overridden version of the temperature property with a different default value. Let's run it. And we've got 30 down there. What if temperature in machine has a getter? Let's go to the next line and indent 4 spaces using the tab key, and we'll add a getter here. And remember, if I want to return the value of temperature, which you normally do in a getter, I need to return the backing field, otherwise I'll have recursion in my code. I can declare the return type of this getter if I want, but the compiler can infer it from the type of the backing field in this case, so I'm not forced to. I do get a warning here saying redundant getter. What might I want to do in this getter? I could add validation in there, but it would probably make more sense to add validation in a setter and check the value when it's actually set. Let's pretend that I have some kind of logging system set up, and whenever anyone gets the temperature, they want to log that information. And I'll just kind of fake this by doing a print line in here. And you wouldn't normally want to put a print line in a getter because then it's always going to run and it's going to be really annoying. But let's write in here, getting temperature from machine, so that we can see that that getter is actually running. And here I could put in the value of the temperature as well. Now, because I've overridden the property here, the property in computer doesn't have this getter anymore. Let's prove it. So down here, let's say val machine equals machine, and I'll get the temperature from machine. Let's say print line machine dot temperature. So when we run this code, I find that I get a Stack Overflow error. Why? Because I've referred to temperature in here. So this is going to invoke the get method itself, and we have circularity, as you can see from this little icon here. Anytime I get the temperature in the getter, I need to return the value of the backing field instead. Now it works. When I run it, you can see we're getting the temperature 21 from machine, we're getting 30 from computer, and when I get the temperature in machine, it's invoking this get method. It's not invoking this get method when I get the temperature from computer because I've overridden a property and I haven't then got that get method anymore. I can add in a new get method in computer though if I want. Another thing that I could do is I could change this to var and I could add a set method if I want. So you're allowed to override immutable properties declared with val with mutable properties declared with var, because essentially all you're doing there is adding in a setter explicitly or implicitly. You can't override a var method with a val, because in that case you'd actually be hiding a setter, and you can't do that. You can't take something that was settable and then stop it being settable via this method. Let's add in a setter here. So set value, and we'll say field, remember we have to use the backing field, equals value, and if I want I could do some validation on that. But here, just to make it clear what's happening, let's just put in a print line. Setting temperature in computer. And now, even though I can't set the temperature in machine, I can set it in computer. So I could say here computer.temperature equals 40, which is a bit hot. Let's run it. And now we're setting the temperature in computer and it's set to 40. When we override a property like this, we have to declare the overriding property with a compatible type with the property in the superclass. So here, this is going to be of type int because I've set it to an integer anyway. So the inferred type of this is int, which is the same as this, and that's fine. I can't, for example, make this a float because that's not a compatible type. What is a compatible type that's actually different? Well, let's take a look at an example of that. I'm going to go up here and let's declare a class called ID. So I'll just leave it at that. I won't actually bother giving it a body for demonstration purposes here. So machine could have a ID property. Let's say here val ID is of type ID, and I'm going to have to initialize it, so let's set it equal to a ID object. Now I decide that I want to override ID in computer. So in computer, let's create a val ID which is also of type ID and set it equal to ID. When I look at the error, I find again that it's hiding the value in the superclass. I've got to use override here, and then I'll get an error telling me that ID in the superclass is final, and what I have to do is make this open. Now it all works, and I haven't actually changed anything here, but I can do. Let's imagine that we have a derived class of ID. So let's have a class computer ID, and I'm going to say that that derives from ID. If I do this, I get an error on ID telling me that this type ID has a constructor and must be initialized. So it has an implicit constructor that we haven't explicitly defined, and that constructor takes no parameters. So I just need to have round brackets here, and then it's happy, except that I get another error, ID is final. I've got to make this open if I want to create a derived class, and now we're okay. Now I can actually change the ID in computer here to be of type computer ID, and I can't set that to an ID now, but I can set it to a computer ID, and that all works fine. If I try to run this, everything's working perfectly okay. So this is what is meant by compatible types. Here I've overridden a property, and the property has a different type to the one that it has in the superclass, but the type that it actually does have is of a derived class from the type that it has in the superclass. So a computer ID is a kind of ID because it's a derived class from ID, and that means that I can override this property with a compatible type here. I can change ID to computer ID because a computer ID is an ID, being as it's a derived class of ID. Okay, that's it for this video. Let's take a look at what we've got here. So this is all the code that we've got, and you can also find this on GitHub. If you go to github.com/caverprogramming, you'll find all my repositories there, including a repository for Kotlin. It's going to seem pretty complicated if you're really a complete beginner, and to be honest, it's pretty complicated anyway. But if you practice this just a little bit, type out the code, get it working, see how it works, you'll quickly start to feel more at home with it. So until next time, happy coding.